So here we need to find the smallest positive integer of mod 11 that is congruent. So congruent means identical to two of these digits. Now all this means is that we just have to work in mod 11. Okay, so literally mod 11. So this is a cycle. Now how do we do this? So the first term 58. So we can firstly say, what is 58 mod 11? The key idea, and this is a very handy trick for, not digits that don't have massive powers, is to firstly you go two ways. First way is a cheap way. You keep subtracting 11 until you get a very small positive integer number that before it becomes negative basically. So in your calculator, you can just write 58 take away 11. And doing that, you get 47 mod 11. So it's just cycles 11. And take away that answer by 11. And then you should have in your calculator answer minus 11, which is 36. And if you keep smashing the answer button, equal button, you'll eventually get to simply 3 mod 11. And that's the end. Alternatively, what we could have done, you can use the remainder theorem, which is like the regular binary method. Just do 58 divided by 11. And then change as a mixed fraction. So 58, so you can put here 58 divided by 11 gives us goes into it 5 times with a remainder of 3. And all we care about is a cycle. So it has after the 5th cycle, we have a remainder of 3. So the answer would be 3 mod 11. This is probably an easier way actually. So let's try that for 581 now. So 581 mod 11. So using the remainder theorem, you can just say 581 take away 11. That should give us, change this to a mixed fraction in your calculator, you should get 52 and 9/11ths, meaning the remainder is going to be 9 mod 11. And that's your answers for both. Okay, next one. So here we need to find the remainder on division by 11 of the following 3 types of sums and products and powers. So what this instantly means, you can use one or two methods. I always use the mod 11 method. Always use modular because it just makes life easy. And here you're just finding cycles of 11s. So let's have a look. So firstly, to make this life easy, what is 58 plus 581? Well, smash on the calculator and you should get exactly 613 mod 11. Now to find the remainder, use the remainder theorem and just divide this by 11. So we can say 639 by 11 and convert that to a mixed fraction. You should get 58 and 1/11. So technically the final result for this one would be 1 mod 11 because we only care about the remainder. So it has a remainder of 1. As for question 2, same thing applies. So just smash 58 times 581 in the calculator. You should get a ridiculous sum of 33,698. And to find the remainder, divide that by 11 too. And convert that to a mixed fraction. You should get exactly 3,063 and 5/11. So it has a remainder of 5 mod 11. So a remainder of 5. Now, the final one is also quite straightforward, but we need to use a very particular theorem. Now, this theorem is quite beautiful actually, because it actually instantly solves this problem. So you might be familiar with this one, and the key idea is to take the base number a, and when you have a prime value like 11, which is perfect, we can say a to the power p mod that same prime value gives you itself a. And trust me, this is one of the most famous theorems in history, and we should thank a particular mathematician. Now, one of the cool things about this is that we can also use some indice rules. We can times both sides by a to the power negative 1. Because remember, this is a to the power 1. If you times it by a negative 1, they cancel out and you're left with a whole 1. So times in both sides by that, you should get a to the p minus 1 mod p, and times a by a minus 1, you get just a whole 1. So this is another beautiful one. Now, why are we doing this, you're wondering? Well, look at the figure. You cannot smash this in your calculator. You're going to get a math error. You can do it on a computer, but you ain't going to bring a computer in the exam. So for those doing it manually, we need to use this theorem. So first things first, let's copy this in. So we got a is 581, and I'm using the second equation because we want it equal to 1, because at least 1 is easier than equal to 581. We can say a to the power of the prime number, which is 11, minus 1 gives us 10. Mod 11 is identical to 1. Now, how can we relate this to 20? Well, if you just times this by itself, that actually gives us, firstly, that's the same as 581 power 10 times 581 power 10. And we can, of course, add mod 11. Now, we both know that both of these, this equals 1. So this means literally 1 times 1. So 1 times 1 mod 11 is 1 mod 11. So the remainder is 1. Well, bravo. You know what? This was art. If you guys enjoyed this one, let me know. And really check this out. This is really cool method, and I can't stress how good it is.